In this lecture, I'm just going to share a few notes about collision detection, which you're going to need to implement for assignment 5. So I'm going to start off here just with the definition of collision detection. It's determining if two or more objects have intersected with one another. For assignment 5, we're not going to worry about if the shapes have intersected with one another as they're moving around within the world, but we are going to worry about if a shape has collided with the bounds of our world. So in this particular instance, this particular circle down here has collided with the bounds of our world, and we want to prevent that from happening for this shape in the lower right hand corner. If it were to move to the right or down, it would have a collision with the bounds of the world. So what we're going to do in assignment 5 is actually, the shape's going to collide with the bounds of the world, we're going to have it turn around and move in the opposite direction. Now, in determining the bounds of their shapes moving around our world, we can make a simplifying assumption by putting in what we call a bounding box, which will give us a decent estimate of the bounds of our object. And so the way this works is that for each object that we draw within our world, the XY location is the upper left-hand corner of our object. And then our object is going to have some type of height and width. So here we have drawn an ellipse. Its upper left-hand corner is the XY location. That's the location of our object within the world. That's going to give us our upper left-hand corner. And then if we want to calculate our lower right-hand corner, well, we can take our width and add that onto x. So this x location is x plus w, and this y location is going to be our y value plus the height, so it's going to be y plus h. So we can end up calculating each one of the four corners of our bounding box. The two corners that we're most interested in are our upper left-hand corner and our lower right-hand corner. Now, once we have that bounding box, we can determine if that has overlapped with a wall. What we can do here is we're going to have a situation where we've got a vertical wall, and to determine if this object has overlapped the wall, in other words, it's collided with it, we can check to see if left-hand side is x's location is less than the wall's x location. And then if that's true, and the right-hand side of the bounding box, if that's greater than the wall's x location. So if this is less than, and this value over here is greater than, that we know that this object has overlapped our vertical wall. So in doing this, we're going to end up writing some if statements like the following to determine if we're going to have an overlap or this intersection occur. That describes a situation where the movement's already occurred and we've overlapped. In our assignment, we actually want to prevent it from overlapping the wall, intersecting the wall. We want to prevent that movement and have it turn around. We want to determine if the next move is going to cause an overlap with the wall. So the only thing we need to then account for is the movement that is occurring here and add that on before we do the actual movement. In this example, let's pretend we have a left-hand wall. We have our ellipse here. Here's our bounding box. And we want to move in the x direction. In this example, let's say that we're going to move a -7. So what we need to do is take our current x location for the ellipse, which is going to be the upper left-hand corner, and we're going to add on to that the movement x, and here which is going to be -7. And we're going to see if that is less than the x location. In this case, it's going to end up being less than 0 because we know that the left-hand side of our wall is at 0. If that's true and our right-hand side of our object, if it were to move, is greater than that, we know that that would cause an intersection. So here I've depicted what would happen if we actually moved the object over a -7 units. There would be a collision there. So what's going to happen in assignment 5 is we want to detect that the next movement would cause a collision, and then what we're going to do is prevent that movement from occurring and actually have our object turn around and move back in the opposite direction. Now for this assignment, we're just going to make a simplifying assumption that you can put a bounding box for your shape. So example, if we've got a hexagon, you're going to your bounding box is going to be your upper left-hand corner, and then you can use the height and width of that to calculate the lower right-hand corner of your object. For a circle, it is true that you don't have to do a bounding box. You could use the center of the circle and the diameter to actually know the exact bounds of your circle, but it's okay to just simplify your work and to use a bounding box even for the circle. So the last thing that I want to show you here is an example of the assignment running. And here, what you're going to do is you're going to add specific movement for one type of shape that is going to move vertically. So here I've got the circle and the spotted circle. Those are going to move vertically just up and down, where my hexagon is going to move horizontally back and forth. So what happens when the shape hits the wall, it's going to turn around and go in the opposite direction. So they're just going to continually move back and forth. For this assignment, we're actually going to shrink the size of the world just so we can see our objects move a little bit quicker. The other thing you're going to notice here that we've added the functionality that after every specified number of collisions, the objects are going to change color. So if we watch this here just for a little bit, we'll see here that I've got it set up that for every third collision with the wall, a circle is going to change in color. So that green just changed in color. So we changed to the green circle. So there's one collision. There's a second collision. Now when this green circle hits this wall here, it's going to be the third collision. So it's going to change color. Now it changed to red. So for the circles and the spotted circles, every third collision, the main color is going to change. For the hexagons, it's going to be every fourth collision that they're going to change. So this is just a little demo of your assignment. The assignment will take some extra time because you've got some problem solving. You're going to have to figure what needs to go in your abstract base class, but it should be a fun little assignment to work on. So that's a few suggestions and some notes about some information you'll need for assignment 5.